everybody. When I came here this morning to this awesome venue, I got this feeling that, or why everybody might think, or why you won't get the impression that containers are already everywhere. I mean, they run on the demos here. You probably use them during your day-to-day job for running your software, for doing DevOps, for developing. They are standing even outside of this nice tent. And but now I'm here to talk about a new frontier of containers, where container technology still has to go, and it's billions of them. So I'll talk about the device world, or devices. We have to see what are devices. Device is a bit of a generic term, and here's a picture where I try to show what I mean when I talk about devices. On the right side, you see basically the word that I guess everybody here in this room is working on. It's a data center world, it's a cloud world, it's virtualized. It's where the massive brains in the future of compute will run. And then basically, if you look on the further left, there is this new world of the things. Those are sensors, those are actors. They will be everywhere in the future, and everybody is saying that they will come along. And then in the middle, that's basically the part that I want to focus on during this talk. Those are devices that have proper computing units that are already around us. So if you look to the left or the right, you see Wi-Fi routers probably running Linux, and that will in the future be more and more around us. So, for example, look at the kiosk system you can see here. Those run Linux. You can look at the router system that you can see. IoT gateways will use that, and then obviously drones and robots will be powered by Linux already. And we at Pantacor believe that that's basically the new frontier where containers have yet to go, and that's where we invest in to basically bring us the benefits that all of you know from the cloud compute there, so that everybody can more easily update their software. So what are devices compared to like systems that run in the cloud? And I try to give a small definition here, what I think makes a difference there. It's that basically those are compute systems that interface somehow locally with humans, with things or other devices. So the difference from a virtual world in the cloud is really that you have peripherals, that you have something to interact with, that you have something that is meaningful to a local environment rather than something virtual that can live in the cloud. Yeah, right. And now I go for an example. So we have basically we start devices. They can start like this. This is a router. Has like a MIPS CPU architecture. It runs 8 megabytes of storage, so it's not much, and it has 64 megabytes of memory, and it runs currently Linux and OpenWRT. This is probably one extreme of the devices that you might find. Then we have this Alexa, or this Amazon device, which comes with 4 gigabytes of storage. It has 256 megabytes of memory. Comes with a price tag of roughly $70. And then on the other extremes, let's say you have a kiosk system that is very low volume, is made custom for the environment it's run on, like at McDonald's or other stores. And it comes pretty beefy specs and might cost easily $1,000 or more. And then obviously you have routers and you have robots and drones, which I didn't list on here. So what are the challenges of the devices ecosystem compared to the cloud? At the moment, I think the main challenge there is that the way the devices are made or operated are kind of like you might have known it from the server world a decade ago, but even worse. So it usually starts with somebody sitting down and say you want to make a product, you make a design a firmware that you want to put on it, you design the hardware, then you start developing it, you make all that, and then in the end you put it into a factory, and once it comes out of that, you never touch it again. It just stays as it is. It will be on the walls, it will be sitting there forever, and if it works, it's great, and you cannot do much with it. Now, what is the problem with that approach? I mean, this approach obviously has a very bad problem, that's security. I mean, if you think about the routers you have at home, how often is somebody updating the firmware on it? How often do people patch security holes in it? They usually don't. Simply because it's this mental model. I mean, you build the hardware once, you ship it, and then you have made money with it, and nobody will ever pay you for any maintenance, for investing in security updates, and doing all that. And the other reason why people are not doing it is because it's technically not easy for them to do. It's if they roll in a security update, they did it actually once from my telco. They sent me a security update at 3 a.m. I was working and hacking all night long, and suddenly the router was down. What you usually do when the router is gone, you unplug the power. So I did that while it was flashing, and it was dead. So that's a huge operational cost. And if you go back to a risk, and if you go back to that price tag of $15, you ship a device like that, then, I mean, how often do you want to send really somebody out and do maintenance, replace that device, and so on? So that was huge cost for them. They had to send somebody to me. They had to basically reconfigure it, a new device for my cable modem, and so on. And so nobody really wants to do that. It's for them, if it happens once, the cost is like 10 times as much of what the device actually cost. So they shy away from that idea altogether. Further, those devices, I mean, what I believe, or what we believe at Pantacor is that not only is it security, I mean, that's a big problem, and it will certainly at some point become a very big problem for society. But if you think about the vendor and the guys that put the devices in your home, let's say a router, those guys are losing opportunity to really give the users a service that is valuable, that is potentially able to generate revenue. So how many devices do you want to have at home? Probably one, maybe two. So maybe you have a router, maybe you have a TV. Then how many more do you want, for instance? You probably don't want that many. However, if you think about IoT, there is this move towards somebody wants to control your home. You probably don't do that directly from the cloud, so you need a device at home. So you need to convince somebody to put a device in there at home. And doing that is a huge cost. And once you're in there, you basically want to leverage that position. You want to be able to change as the market changes. So you have a router in there, and you offer maybe a very basic IoT home control solution now. So what you want to avoid is that now there is a competitor coming up with an amazing new feature, something that just makes people replace your router at home, and then you are out of that real estate at home, and people can basically you have lost that what we call a real estate at home, where you can make money from. But envision a world where you could then react on that kind of market innovation by sending a software update to it, by potentially sending out a few more peripherals like a Bluetooth dongle that you can basically modify the device to start controlling your home in the new way. Then you can potentially leverage the position that you have once gained with your device to generate revenue opportunity and basically extend your business model beyond the first sale price that you are making. And actually, I think that's where the industry is heading towards, or has to go, because in the end, for a $15 price tag, you will not be able to do security updates. So you have to find a way how you can actually justify investing in technology on the security side, and by having the ability to deliver services for rent, for lease, something like that, you might have a good business model there. Thinking even further, if you're a telco, you might want to go down the road and say, I don't even know what is the great IoT solution, but I am at home and I have that device there, so why don't I rent that out to whoever wants to offer an IoT solution? So getting the ability to deliver software safe is the future for devices, and it's absolutely necessary to do that. So that's basically how we believe devices should be made. So you don't end up trying to design the perfect device, which includes software, which includes all the features you want to deliver for your users, and they should last for 10 years. But you rather pick something very generic, something off-shelf, some kind of a Raspberry Pi, for instance, a board. Then you wrap a chassis around it, and you add the peripherals you believe will be very important in the future, and then you ship it to your customers with an initial version of software, and then when basically the software, the device is taken online, you basically have the opportunity to change out what is really run there. That can be custom per user, that can be custom for an operator. So somebody in China making a router, a white box labeled router, can just pre-install software and give it to any telco in the world, and they can decide when this device first comes online what to put on it. And then you basically can use that to sell it early to the market, so you can get ahead of the curve of the competition. Then you have a device at home, and then you can just observe and monitor what is the competition doing in IoT, and whenever it happens, you work with an ISV or with somebody who has a great solution and offer that to your customers to basically ship that to the user. Right, and that's basically how we believe you can gain lots of things. For instance, security, as I said, you get the opportunity to really enter markets that you haven't thought about before. So you might not have known that a router might become a great IoT gateway when you started producing it, but then at some point you realize that's the case, so you can potentially use the USB sockets to ship a Bluetooth dongle to it, then you can have some nice other peripherals and add value for your customers later. And then obviously by offering services at home, you might be able to get revenue from it. So obviously, how can this be done? We believe containers are the way to go there. So I want to now talk a bit about how containers on devices are currently used and what we do there to help the ecosystem to move forward. So what are containers? So containers for apps is, I think that's what most people use it these days. You package something up, and it's a great packaging system. It solves all those problems you had in the past of how can I get software packed up and give it to someone so he can run it independently on what kind of hardware he's on or what kind of distribution he's running and so on. So in the past you had to figure out, do I do a dep, do I do an RPM, and so on. Containers solve that by being kind of a perfect packaging system. You can easily share and reuse them. So Docker has shown how great there can be a development experience around containers where you can post something, people can use it, you can change it, you can modify it, and then you have your own thing that you can, again, reshare to the world. And I think the biggest thing of containers really is, me as a Linux guy, is that you get the whole Linux distro ecosystem as your SDK. So you're not trying to get an SDK which is limited in any mean. You can take whatever packages are existing in the open source world or proprietary, and you can really use that for your development. I think that's a super strong reason why containers are strong in the current devices, in the current application world, in the cloud, and that's definitely also a reason why containers will also be useful on devices. So now there are already people experimenting with containers on devices or teams, and I picked two examples. One on the right side is called Resin. They basically use Docker to run one app, or I think also many apps, on a device that is otherwise not modifiable. They have a cloud solution. They come with a complete build and CI story for it. But you basically have to buy in their development model, their CI solution, in order to do that. And they also do not look at what you can do on the base system itself. So in particular, what are you doing, what peripherals, and how do you really talk to the hardware that a device is about. Then we have I found something super interesting as well. That's Elliot. They really said, what is a device? A device is really a pod. And the pod has one to many containers, so you can put that together, and you can manage it with Kubernetes-style toolset. I don't think that has really gone off in production somewhere, but I like that idea. It is kind of interesting to see, and has a very good local development story, how they have basically done it. So let's look at this Resin host OS architecture and what they are doing. So they have basically just taken what you would normally do in a cloud. I mean, you would take a normal system. They took a Yocto system. I don't know if you know the distribution. Maybe not, because it's more device-centric. But they took a Yocto distribution. They put a Docker in there. They put all the middleware they believe is useful for a device in there. They put network manager in there, as you can see. They have a modem manager in there. They might add other middleware for Bluetooth and so on in those in that host OS that they're basically shipping, and then they have Docker on it, and on top of that, you as somebody who operates the device can then use Docker applications just like you would use them in the cloud, kind of, right? I mean, you basically have something you can package up, you can run it on the device, and they have basically a complete CI solution to roll updates to it, focused on the application, though. So now we believe there is a problem with that approach. I mean, obviously, it's a smart approach. You basically just say, what do we see in the cloud? We directly transfer that to the devices world. But then, as I said before, the devices world is not special in that it's a CPU that you also have in the cloud. In there, it's really special that there are peripherals, and that you want to be in charge of what you can do with those peripherals, and especially you want to be able to more easily swap out what you can see here as a Resin host OS. You might not want to use that stack, right? Why would you want to use Network Manager on a router, for instance? Maybe you want to use it on a robot. I don't know where you want to use it. However, making that call for the whole device world that this stack is what you need is kind of a big fetch forward. And then also, as you know, Docker, they are not very good in interfacing with hardware. Obviously, you are isolated, you are virtualized. That's the whole idea of it. You don't want to know where you're running. And so there's not really any there's no support built in to really support that quite well in that ecosystem, and people are not really focused on that as well. Also, Docker is more about describing and sharing apps, but not of the complete system. So if you're operating a device, you don't necessarily care so much about what is this one application version on that device, because in the end, you want to ensure that a device is made up of certain components and that it has exactly the combination of components that you want, and don't want to have a mix and match of things that you don't want to control. And Docker doesn't have that built in. Then there's things like Docker Compose or things like that, but they don't really reflect all the elements of a system, for instance. You cannot describe the Linux kernel in there. You cannot really describe those middleware points, even though I think Rancher has packaged it up as containers individually, which is also interesting. So you might be able to transfer that idea to the device world. And then, last but not least, that's something that we found is also super blocking the adoption on devices, and that's the disk footprint of Docker. It's pretty big if you think about the devices that really make up the majority of devices out of the billions. That's the devices that make up the billions of devices. They have 8 megabytes of storage, or 16 if you're lucky. So you put that on there, and it doesn't even fit, or if it fits, then nothing else fits on the device. So what we did, we basically said, like, okay, let's try to take a look at what a containerized system would really need in order to be operated, and to not be just a copycat of what happens in the cloud, which was obviously designed and optimized for the cloud, but what are really the elements we need to put together in order to give containers to the devices world. And so one big thing is that we believe containers should be used not only for the apps themselves, but for the system software itself. Because if you think about a router, it might have 16 megabytes of storage, or maybe 32, or maybe 128, but in the end, the core functionality is still this main firmware. It's like an OpenWRT-based system, usually, that manages the Wi-Fi, the connectivity, and so on. And that basically is something you need to update in order to really provide security updates, or in order to provide new features for it. And we believe strongly that system containers are very important to get there. And then we basically developed a tool that's called Pantacor. That's what is our kind of mini Docker that runs the first process on any system, and that is pretty dumb in the sense that it only focuses on bringing up containers, system containers or apps, as you like it, and they completely run outside of the system. So you don't need to integrate it. So there have been solutions to try to integrate. Let's integrate Docker into the main system software stack. Then you're going to have the problem: how do you manage basically the system itself as a container from inside, or updating the system from inside is always bad. So we said, let's build something that sits on top, and that just can have a look on top of the system and the applications in parallel. And Then the next one is we have a JSON that describes the whole system, so every bit that is on the system can be described in a JSON, and that's basically what you deliver to the device, and the device will ensure, or Pantacor will ensure that exactly those bits are running and nothing else is there, and you don't diverge over time. That's basically gives you the ability to be really in charge on what is running on a device. And then we wanted to preserve this ability, which you saw on Docker, that you could easily share the software with others. So you can get this ability, you can show people your device, they can use it, they can modify it, they can transfer it into their own use case. And we basically did that through our cloud endpoint solution called Pantacor. So this is our architecture of the system. So it's all open source. So both the server side as well as the client side, because we believe it's bad to tell people like adopt this, and then in the end you can basically screw them because you have the proprietary cloud side. So Pantacor is a minimum set of microservices which provide basic endpoints which allow you to deliver software or configuration to those devices. So you can basically deliver such a JSON that I just talked about, which describes the whole device to a certain device endpoint, and then the device will see that, and it will move to that state. And if it fails, it will go back automatically. It is written in C, Pantacor, on the client side. It is because we needed to have it to be small. We wanted to be able to run on 8 megabyte devices. We ended up having something only 350K in size that gives you the ability to run applications and systems as containers. It gives you the ability to talk to the cloud with TLS. And it also ensures that the kernel and the initRD, I'm not sure how familiar you are with the internals of Linux systems, can be updated as well in a fail-safe manner. Fail-safe is super important for devices, obviously, just to show the difference of the cloud. In the cloud, you can just spin up new VMs if one thing is dead. In the world of devices, you cannot do that, right? I mean, you have a device that sits on the wall. If that thing is bricked, you have to send somebody for maintenance. That's costly. Nobody wants to do that. And you basically start being risk averse. You don't want to send new software because you might get the feeling that it might break. So we have a mechanism that allows you to send broken kernels, for instance, or broken init-RAMFS systems as well, similar to applications. And then there's a way to determine if a boot was successful, and if the boot was successful, it will go to that new revision of that device. Also, this picture shows a bit of more of a typical use case of what we believe the containers will be in. It will not be initially like in the cloud where you put like hundreds or 10 or 20 different applications as containers on a device. We believe it will all start with using containers for the main system, this OpenWRT, which we have shown here, and then you will maybe add 1 or 2 applications in parallel to it, which then can be other complete systems again that you give access to the video card, so you can have a router that does a Wi-Fi connectivity with OpenWRT, and then you can put maybe next to it an Ubuntu that gives you the on-screen display, for instance. Exactly. But we don't think that initially, in order to get the ecosystem to move to this new world, we don't need a solution that is really made for running apps and app stores and so on. I personally come from the Ubuntu team, where we have been investing in these things, and you might have heard about that as part of Ubuntu Core. Right. So with that, you basically get the ability to have firmware teams. Let's say in China, they make this OpenWRT firmware, and that you put on factory, but then you as an operator can then put your apps next to it without risking also the connectivity app itself. All right. So these are 2 components that we basically have there. As I said, they are all open source. On the left, we have something, we call that Pantacor, that sits on a device as a process that governs everything that runs on it. It is open source, MIT licensed, so we don't run into issues because device manufacturers usually don't like GPL. I mean, they just don't like it. they prefer if they can avoid these and the license hassles they might get out of it, or they think they might get out of that. It runs on ARM, Intel, and MIPS. MIPS is pretty strong in that world as well. Is kind of taking over a bit there, but I think it will take quite a while until we really get to a state where all the devices have enough horsepower to be like Intel is now. Then we have a footprint of 350 kilobytes on disk and 1 megabyte in memory. So we have, as I said before, super small and tiny. Then you have an ability to use LXC as systems or potentially Docker apps. So in the scenario where you really don't have much disk space, we use an LXC runtime at the moment. But we could also write one ourselves eventually. But LXC is pretty neat. It's pretty small. It's all written in C, so it was easy to just use and adapt. Pentavisor has fail-safe updates, so you can send new revisions to it, and if those revisions fail, it will automatically go back, report that back to the cloud. Then you can inspect it and can think what to do and send a new update to the device. You can have inside your systems, you can implement custom health checks. So if your system like an OpenWRT or your Ubuntu, you need to give feedback to us. When does it break? Is it broken? Should I reboot? Should I go back? And so on. Or is it fine where I am? And that logic is not always easy to guess from outside in a perfect manner. So we give the ability to do that inside of that. And we will have pretty soon error and crash reporting to basically give you the ability to really debug efficiently what's going on in the field. So that's, I mean, usually you don't have the device at hand and you want to see what's going on, and you want to basically also try, maybe give the update to a few devices first of the fleet of 1 million, and then see when something is breaking, really investigate that, and this feedback needs to be there. Then on the cloud side, that's we call it Pantahub. It's kind of Docker or GitHub for devices. I cannot really say which one it is. It's kind of a hybrid approach. It gives you the ability to really, so it basically has this knowledge about those devices endpoints that pop up, and then you can manage the state of those systems in revisions, like in a Git-like manner. So you can basically see the revisions a device has walked through, and you can also push that as individual steps there. It's a set of REST core APIs, so we don't have directly things built in like a large-scale fleet management. We believe that's something for somebody else to build from outside. So you basically get an endpoint for every device that you have, and then if you want to have a rolling update to 1 million devices, you can have something sitting outside to talking to the microservices to do that for you, usually integrated in your existing management software that you already have as an operator, for instance. So having like an off-shelf solution might be at some point on our roadmap to do like large-scale device fleet management, but we believe that operators will rather integrate that into their existing systems initially. You can then manage the device firmware, so you can basically get what's currently running on the device. You can share your device with others, and we operate our own instance as a freemium service, so everybody can just go and subscribe there and start using it. But however, you can also run that by yourself because everything is open source. Right. Factory compliant might also be interesting because usually factories produce like a device, they put a certificate in there, so you need something that is smart about onboarding those devices that come on, and they have to route them to the right owner, for instance, in Pantahub. We're doing that as well. All right, so maybe let's see if I can show something off. All right. I would see my cursor. All right, so that's Pantahub. I can log in here. Then basically on my page, I get some info about the quota and so on. And as a developer, you need to kind of get your device that has come on for the first time. You have to claim that it's your device, so there will be kind of a challenge that the device is giving you on the console, or through Avahi, you can basically see how you can have a device that is on your local network, how you can claim it. And then you basically can take a look at all the devices you have. I've started a new one here before we got there. So you can see one thing that is interesting is that it's a clone URL. So you can basically now go and, let me see if I have it here. That's not yet in the UI. We have now more meaningful names than just the IDs. So the interesting thing is you can, the tool we use to talk to Pantahub and to manage your devices is called PVR. Pentavisor remote or whatever you might call it. So what you get then is basically you get a complete clone of what is running on your system locally. What you can see here is the system is made of a few things. It has, well, maybe it's a bit larger, don't know. At the bottom, right? Well, okay. Right. So we have the kernel image here. You have the leader root file system as a scorchfs, and then it's a JSON description of the leader, how you started, what the namespace properties are. Do you want to share the network namespace? Do you want to share the mount namespace and so on? Then this one is an LXC-based image. There you can just configure your LXC runner. So you can see how that is made up. Right. And then we have also something called a writable. In this case, you can basically ship a writable partition as an X4, but usually you might also just refer to the main storage in your LXC config. So if you now want to change something, I don't know, I won't change now anything big here, but some null up. Then you use PVR commit to commit the changes you have done, and then you can use PVR post to post that change to your device. And if we are lucky, and I find my mouse pointer here, you can see live the logs if it would be better, more readable. That it downloads any objects. It starts rebooting, I think. Right now, that's basically a device that runs in the cloud in a QEMU instance on MIPS. So then you see it basically rebooting there. And once it comes up, it will show up as updated, and the logs will continue to flow. You see at the moment it's in progress. So it's going for revision 2. Then you have the new system booting, it's running. It's a bit slow because it's virtual in the cloud. I don't know what's going on with my mouse. Ah, now it had an error. Whatever. So then you see you have a publish button there on the top. Once you have a device that is happy and you want to share it with the community, you can do that. Now, yeah. I don't know why my mouse pointer doesn't work anymore, so. Oops. Don't know, could be that it took so long to come up. We have currently the logic in there that it takes 60 seconds or something in order to get network, otherwise it will consider it broken. All right. Okay. I think time is up, right? Okay. So, okay. So if you want to have more discussions about this, feel free to reach out to me. Happy to take the rest to the hallway discussion. So, okay. Thanks a lot.